Hi there everyone, welcome to this revision video looking at one of the final questions that's going to turn up in your Edexcel GCSE paper, and it's an AA star topic and the topic is known as bounds. So we're just going to spend a couple of minutes in this video looking at the concept of bounds, help you understand it and help you look at the laws or the rules for using upper and lower bounds. So the first thing I want you to do is kind of get out of your mind the idea of rounding, because these are different concepts. Bounds is talking about limits of measurements. It's talking about the maximum and minimum values that something could be. So let me give you an example to start with. Let's say I've got the value 50 and I've rounded that to the nearest 10. So if I represented 50 along a number line, and I'm just going to draw one in here quite roughly, 50 to the nearest 10 means my number line is travelling in tens. So the next 10 up would be 60 and the 10 before it would be 40. So I've got a number line represented in tens. So 40, 50 and 60. And we're talking about the value of 50 in the middle here. Now, bounds are simply the maximum value at which 50 could still be called 50 to the nearest 10, and the minimum value at which 50 to the nearest 50 could still be called, sorry, to the nearest 10 could still be called 50. So we're not talking about rounding, because rounding, since we were in primary school, told us that 5 or more we round up and less than that we leave it as it is. We're talking about the limits to which these numbers then change. So if I'm talking about my number line here and I'm going from 50 upwards and I want to hit the point at which it would then change to 60, I'm talking about 55, because 55 is the point at which the value then changes up to 60. So 55, for this example, is what's known as my upper bound, or my maximum limit for the value. Okay. On the other side of things then, and we could kind of work backwards and look at 40's upper limit to understand 50's lower limit, but let's work our way down from 50 and understand the value at which it would change to 40, and that's going to be 45. So 45 would be my lower bound, or my minimum limit. And that there is the concept of bounds. It's talking about the value that's above it, that would then be the change point between the values, and the value below it, that would be the change point between the values. A lot of teachers often saying, kind of trying to remember this in a simple way, it's always 5 above and 5 below, or 0.5 above and 0.5 below. So we're never talking about 0.4s and 0.499s and those sort of things. It's always a 5, whatever unit you're talking in above and below. But this, I hope, helps you understand the concept of why. Now, a bounds question, if it comes up in your GCSE, might be nice and simple part A, something like this. Here's the number 50 rounded to the nearest 10, state its upper bound. And that would be nice simple 55 for 1 mark. What's more likely to happen in your GCSE is they're going to talk to you about a calculation involving bounds, and we'll have a look at some of them in another video. And what you need to understand is when you're doing calculations, whether you're going to use the upper bound or the lower bound. So let's kind of help ourselves establish a table here, and we're going to have a quick conversation around when we use the upper bound and when we use the lower bound. So if I wanted to maximize my overall answer, or if I wanted to minimize my overall answer, let's have a think about whether we use the upper bound or the lower bound. So if I was multiplying two numbers together, so let's think logically. If I wanted to find the biggest answer possible timesing two numbers together, then logic would say, well, I times the two biggest things I can possibly times together. So to maximize a multiplication calculation in bounds, we're going to take the upper bound and times it by the upper bound. So for example, if this was an area question, you times the upper bound of one length by the upper bound of the other length to maximize your value. Logically then, to minimize it, we would multiply the lower bounds together. And this is going to be a really useful table for you to remember, and we can use the kind of rules to apply them to some questions in a minute. Now, if I was adding, again, let's have a think about how we'd maximize the value. How could you add two numbers together and get the biggest outcome possible? Well, again, logically, that would be by adding the two biggest numbers available. So I would do upper bound plus upper bound. And if I wanted to minimize my answer, I would add together the two lowest numbers possible. So those two are quite straightforward. If you're maximizing a value when timesing or timesing or adding, use the upper bounds. If you're going to try and get the smallest amount possible or minimize your answer, when timesing or adding, use the lower bounds. Subtracting, however, let's think logically. If I'm going to subtract one number from another and I want to maximize my value, I want to get the biggest answer possible, what we're logically saying there is we want to get the biggest gap between the two numbers. So what we want to do is the upper bound of the first number, so the biggest number I can get, and I want to subtract the lower bound of the other number, the lowest number I can get, because that's going to maximize the distance between them, so that will maximize a subtract calculation. Minimize then would be the opposite. Take the smallest value of one number and subtract the biggest value of the other number to squeeze down, to minimize the gap between the two numbers, so we get the smallest answer possible when we're subtracting. And that leaves us with our final one of the four types of calculation, and that's divide. If I want to get the biggest answer possible when I'm dividing two numbers, well, what I'm going to do is I'm going to divide the biggest number I can by the smallest number I can, because then I can fit more of these into this. And similarly the other way round, if I want to minimize my answer, if I want to get the smallest answer possible, I'm going to take the smallest number I can get out of the calculations and I'm going to divide it by the biggest bound on the other number, and that will create the smallest gap possible when dividing. So these four rules are really, really important. How to maximize and minimize when multiplying, maximize and minimize when adding, subtracting, and also dividing, and this is a typical GCSE type of question. So let's apply these rules to a typical GCSE style question and see how we get on. Let's have a look at our first question here then. So we have got question number one. A room measures 433 centimetres by 327 centimetres to the nearest centimetre. Okay, so the first thing I'm going to do, and I would suggest you probably do this in your GCSE as well, because I think it's quite helpful to visualise it, but you don't have to. If we're talking about 433 to the nearest centimetre, that means 433 is on a number line travelling in centimetres. So the value below it and the value above it are going to be centimetres up and down. So 432, 433, 434. And then my bounds are always the limit point at which the value changes, the limit point at which the value changes. So at 433.5, that would be the maximum value I can take before it changes into 434. And at 432.5, that would be the lower bound, the smallest value I can take before it changes down to 432. So my answer then, to find the upper and lower bounds of each dimension, the upper and lower bounds for the first dimension are going to be lower bound is 432.5, upper bound is 433.5. Looking then at the other dimension, the 327, again, that's to the nearest centimetre. So if we had our number line graduated in centimetres, we've got 327. Next one up is 328. The one before it is 326. And our bounds are halfway between these values. So I'm going to have lower bound at 326.5 and then upper bound at 327.5. So that's a typical using this rule that we wrote down earlier, understanding the concept of maximum and minimum values for our bounds. Part B, however, is a really good example of those four rules and trying to apply them to think about which values of the bounds we want to use in the calculation. So we've got write down the greatest possible area and the smallest possible area using the bounds for the room. So there's our four rules. Area, remember, is a multiply calculation. So on our rules to multiply, if we want to get the greatest amount, if we want to maximize it, we're going to do upper bound times upper bound. So for the greatest one, we're going to take the upper bound of the first dimension, which was 433.5, and we're going to multiply it by the upper bound for the other dimension, which is 327.5. For our smallest possible area, our minimum area, we're going to take, looking at our rules, the lower bound for each one. So we're going to do 432.5 and we're going to multiply it by 326.5. So let's get a calculator, let's have a look at those calculations, because then hopefully we'll have a look at and begin to understand this idea of bounds in real life and how it might be a really useful concept if you end up in a profession where you're trying to measure to a degree of accuracy. So our upper bound, our maximum area, turns out to be 141,971.25, and our minimum, or the use of our lower bounds to create a smaller area, the smallest area possible, turns out to be 141,211.25. So we've got a gap there of, what's that going to be, 760. So we've got a massive variance there in the area of this room based on how we've rounded the bounds of each of the dimensions of the room.